Hey, let's continue with this hands-on session. Maybe before we start, or start again, just give me a hand if you have now the example project space somewhere and can open it. Okay, this seems at least a lot better than before. Yeah, but if you don't have it, just Marcus will come to you and maybe we just copy it from the USB drive. But also, it's not super bad if you cannot access the project space right now, because we are the next few minutes just going through a few examples. And if you just look at the screen, you will also see what the features that I'm going to show. Okay, maybe we can start again from opening up the workspace. So if you are in Sirius, maybe it's easiest if you just drag and drop the project space. So this example folder, maybe I can just show it again. So you should now have this folder somewhere, this example minus Sirius minus project space minus structure. You should have extracted from the zip, and you can simply drag and drop it inside Sirius. One thing that I noticed is that with Windows, sometimes if you open up this folder, you can see that there's actually another folder with the same name. Somehow you have the project space inside this folder. So if you open up this folder, it should look like this. You should have really many directories there. But you only have to check it if it isn't working. So just drag this folder inside Sirius. First, somewhere here to the left. And then you get this box that says now you're importing, or you are opening up a project space, and you have to click yes. And then we should all have pretty much the same data. So everybody should have like a really long list of compounds now, and also many of the compounds should have the confidence score somewhere here. So this confidence value. Okay, let's just go in a few examples. We started with this example where we had the feature, now I have to check it again. I think it was 9065. So to open this example, you just have to type in 9065. This is just if we know the feature ID of what we're looking for, of what we want more information on, you can just type it in this bar and you will get to this exact compound. We already looked a little bit at this formula tab. So just to reiterate very quickly, you now have all your molecular formula candidates here in the list. So here you have 10 molecular formula candidates, and you can see various scores for these candidates. And also, you can, of course, see which formula ranked best. I also talked a little bit about the spectrum view at the bottom and the fragmentation tree view, which you can, of course, look at. And these two views, the spectrum and the fragmentation tree view, you also have bigger versions of them here. So this is the spectrum view from before and the fragmentation tree from before. So we are not going to go over them now because you just saw them already. Just one thing to know is that the list of molecular formulas now is at the top. So now we have our 10 molecular formulas here. We have from 1 to 10 our formulas and can switch through them. And if we change formulas, of course, we get another fragmentation tree for each formula. Okay, now let's get to the predicted fingerprint tab. And here you can see, because in this top list, I'm at the second molecular formula hit. I do not have a predicted fingerprint for this molecular formula, but if I go to the first hit, I do have a fingerprint. And just remember, because Marcus also talked about it, right now we are still in the de novo workflow pretty much. So even if you don't have any structure database hits later on, you will see a predicted fingerprint here. So you will see what CSI FingerID thinks that your compound looks like structure-wise. Marcus also explained it a little bit. You have now all your different substructures. You can go through this list, and for each substructure you have a probability. So how likely is it that this substructure is in your compound? And you have a predictor quality, which just is a measure to say how trustworthy the predictor is. But we will see a bit more on this in a few minutes. Now let's get to the structures tab, and maybe this is the tab you will spend most time when you use Sirius, because now we actually get to the structures that are predicted. So before we just looked at the formulas, but now we have a really long list of structure candidates. And again, you can switch the formulas. And if you had structures also for this second formula, you would also have another list here. For this, we only have structure hits for the first formula. And we are just going to look at a few examples here. So each item in this list is a structure, as you can see. You have your structure visualization in the left. Then if you have a few other scores. So there's quite a lot of scores in Sirius. On the right, this is the most important score. This is the CSI FingerID score. And this is actually the score that is used to rank the structure candidates. You can see here it is in the minus, but minus 47 is a pretty good value. So you can see the second hit has a score of minus 231. And another score that you have, but it is not super important to look at, that is the Tanimoto score. This is the one that you have on the left. And this just compares the predicted fingerprint with a fingerprint of this particular structure. We do not use this for ranking, but often this Tanimoto score is more easily interpretable when you look at it. Okay, other things that we have here is the substructures view. So these substructures actually correspond to the ones that we saw in the previous view. So in the predicted fingerprint view, we also had this list of substructures, if you remember. And now we have each substructure that is in this particular structure candidate as a box. And you have blue boxes and you have red boxes. And the blue and red just means that these blue boxes here at the beginning, here we think that these particular substructures are actually also, or in these cases, the substructures are also predicted for our molecular formula. So if we click on such a substructure, which you can just click on one of these boxes, and you will see that some part of your structure highlights. And also this part highlights in other structure candidates. So this amine ring, or this part of an amine ring, also highlights in the second structure hit. And for this part, for this particular structure, because the box is blue, we think that this structure is actually present. So this is a good hit. But if we go to the red boxes and if we click on them, apparently this matches to this particular part. And here our model thinks that this substructure should not be present. But another thing to know here is that the boxes have a different size, and depending on how big the sizes are, the quality or the size of the boxes also notes the quality. So smaller boxes are not that trustworthy. So don't worry if you also have some red boxes for a good hit. This just means that the predictor might not be the best. Another thing that you can do is you can right-click on a structure candidate. And then you have another menu. You can, for example, copy the INCHI key on the INCHI of this particular structure to search it somewhere. You can also open it in PubChem directly. But the thing I want to show here is that you can highlight matching substructures. This is also always a good feature to have. So if you just right-click on a structure candidate and click on highlight matching substructures, you'll see that now many parts of our structure light up. And these are just all the parts that match. So all the parts that match from the predicted fingerprint of the fingerprint of this particular structure hit. And again, we are now searching in structure databases, and these boxes at the bottom are just all the structure databases where we found this particular structure in. So apparently, this structure is also contained in HMDB, and we can actually click on these boxes here. So if we do this for this example, the HMDB page will open up. And we will see now we have the HMDB page of piperitine. And maybe you can remember, although it's quite a long time ago, we got the example by looking at the molecular network of piperine. And this is one of the nodes that was connected to it. So apparently, according to Sirius at least, the structure that we looked, or the compound that we looked at might be piperitine. So it might fit quite nicely. So just remember, you can click on all these boxes to get to the structure databases. Yeah, question?
Maybe a stupid question, but what do the squiggly lines mean in the structure?
That you have to ask someone with more chemical knowledge.
The wavy line? It's simple times, right?
Okay. So another feature, let's just get to the next tab. Another feature that Markus mentioned quickly is that we have a kind of combinatorial fragmenter in Sirius integrated, which takes our structure hits and then tries to annotate the MS2 spectrum with these structures. So now, remember, this is our structure that we looked at, that we found, for example, also in HMDB. And when we now click on one of these peaks, so for example, let's take this peak, so the second peak here on the left, we see that this peak, according to our fragmenter, corresponds to this particular substructure. You can just go over the peaks and see if they make sense for you. So maybe you remember from before that you had the MS2 spectrum and you had green peaks and you had blue peaks. So the green peaks were the ones that could be explained by a fragmentation tree. Now the purple peaks are the peaks that can be explained by our structure using our combinatorial fragment. So you can just go through all these peaks and see if they make sense for you. A good thing to know is that this particular tab is independent from the structure search. So this just is maybe a good thing to know if the structure hit that you gotten, that it is a good hit, because this is independent from the searching process. Another tab that is really important, especially if you do not have any structure hits. So if you, for example, go through your compound list and you see that you have molecular formulas or you have whole compounds where you do not have a structure database hit, you will still, if you have turned on Canopus in the beginning, so remember in the compute dialog, the last button was the Canopus button, and if you turn it on, you will have this tab, and this is the compound class prediction part. So here you can see that for this particular compound and this molecular formula candidate, we have predicted these classes. The classes in the top are classifier classes. So for example, for this compound, we have predicted benzodioxones as a class and organoheterocyclic compounds as a superclass and organic compounds as the kingdom. And you can click on each class on each box, and it will directly take you to the classifier page. Although it currently also is not working right now, but this is a classifier. We cannot do anything about it. You also have alternative classifier classes. So if you do not know classifier, a compound can belong to many different classes. This is not a problem here. And again, you can click on them if you want. You also have natural product classes, which is another ontology, another way to specify compound classes. And here you can see that actually we have the class piperidine alkaloids, which already sounds a lot like the piperidine structure, which we found. So this also might give us a good signal that the structure that we looked at before might be the right structure. Okay, now we went through one example, and because we do not have infinite amounts of time, maybe we're just going to skip the next example and directly go into something that has more to do with the tasks that we also have for this data. So these compounds that we found now, piperine and piperidine, are related to pepper, and probably they come, or the reason that we find them here is that the person from the sample has consumed something with pepper taste. But the actual task always was to find this drug, diphenhydramine. And for the next few examples, we are going to look at diphenhydramine and look if we can find it in our data. So let's just clear this filter at the top so we have all our compounds again. And the question now is, we still have so many compounds, and we could of course go through every structure and see if we by chance find diphenhydramine, but it would take a really long time. And we can use one particular feature of Sirius to really speed this up, and this is the custom database search. So remember, we search in structured databases. You can also make your own structured database and search in it. And this we can do with this databases button. So in the top bar, if you open up databases, you will see this dialog. I hope everybody can open it. And for you, it will just be empty. You will not have any databases imported. But we can just do this now. And the question is, of course, if we look for diphenhydramine, which structures do we put in there? What do we want to find? And one thing that you can do, especially if you do not know the metabolites of diphenhydramine, which you maybe want to find on top of your head, you can just go to PubChem. So let's just go to PubChem. I have this already somewhere. And if it loads, maybe you can just type in diphenhydramine and go to the PubChem page of diphenhydramine. You do not have to do this in this follow along part. I just want to show you where you can get structures to search for in this custom structure database. So for this diphenhydramine page, for example, what we could do, we could go to the section pharmacology and biochemistry. And there, if we scroll down a little bit, there's probably some of you know this, there's this section transformation. And this is a section of biotransformations of diphenhydramine. And each of these particular compounds has, of course, a structure. And we could go to all these compounds also in PubChem and copy the structures and just collect all these structures and make a custom database from it. To do this, we have gone ahead and already provided the custom databases as a zip file. So if you were able to download it, you would have a custom database folder somewhere. I can just show you where how it would look like. But if not, it's also not a big problem. I can show you in a bit how you would create it yourself. So here I have this custom DBs folder. So you should have downloaded some custom dbs.zip file and extracted it. It's a really small file, and there you have this custom DBs folder, and inside it you have a few custom DBs. So I'm just going to show you how you import it. You again go to the databases window, and then you click at the bottom right on the plus sign, and here you can specify a database location that you want to import. So here this window is not really many options, at least not ones that we need right now. We would just click on this button here and then navigate to wherever we put this custom databases folder. So I have it in this particular folder. So you should navigate to your custom database, custom DBs folder. And if you have it, just double click on it. And you will have these 3 custom databases. And we are just going to use the second one. And what is basically in there is just the 4 structures that we just found in PubChem. So the structures that we just looked at in PubChem of biotransformations of diphenhydramine, these are already contained in the structure database. And if you have it, if not, it's also not a problem. But I'm just going to show you how you would import it if you have it. You just click on this folder, you click on open, and then in the end, you click on create open database and import compounds. Take a little bit, and now you have this database imported. Okay, and now what we can do, now we have a custom structure database with 4 structures contained. Yeah, maybe I should ask if everybody has this custom databases, if it worked. Or yeah, maybe you need some time. Which part is it? Maybe just try it again. And maybe a good thing to show why some of you are still trying to import the database. There's also another way. So you can create, of course, this custom database from scratch. And for this, we are also going to go to the custom databases window. And on this, when you click on the plus sign, so just to make it a little bit more slowly, you have this custom databases window, and on plus, you can create or import databases. And here in this box, you can actually just drop some smiles. So you can just take the smiles of structures and drop them in there. If you have the GitHub repository folder somewhere, if you have downloaded it, or if you just have the link, so I can just show you where it would be. So in the GitHub repository, under data series output example, or not, sorry, it's the wrong one. So under the workshop repository, under data and series output, there's this text file, custom db-hydrogen pubchem smiles. And this you can also just open. It contains a few smiles. So maybe for those of you who couldn't import the custom databases, if you are able to access the GitHub repository, there will be a text file, and it just contains a few smiles. So maybe I will just go ahead and show how you would create it. So if you just have some structures as smiles somewhere, you can just copy them and get back to Sirius and just paste them in this text field. So it is as simple as that. You can just paste your smiles that you want to create your custom database with. And if you create a custom database, of course, you always have to specify a name for this database. So again, you use this button here at the top, and there you select where you want your database to be stored. So before you use this button to import databases, but now we are going to select a location where we want to store this database. So just select some location, so navigate somewhere on your file system, click the Create New Folder button, and just name your database. So just maybe call it pubchem -or something. And then if you do this and you click open, now it also says the location here. And you have your smile at the bottom. And you can, again, just like when you imported custom database, you can just create open database and import compounds. And now you see that you have two databases now, which are the same, but the first one will be imported and the second one we created from scratch. So now, how many of you have some custom database if you open the window? Okay, at least that's quite a good share, I think. Do you have a question?
Yeah, for me, the create open database is grayed out.
Yeah, I have the same problem.
Okay.
The bottom is not active.
And also, if you paste something in the...
When I paste it works.
Yeah.
The database.
Yeah. Okay. So then we have to look at it later on. So maybe I can just show you when you have some database, maybe it does not work right now, but we will just in the session or in the part later this afternoon, we can just look why it maybe didn't work, and then we can repeat it. So everybody has some custom database. For now, we are just going to look how or what we would see if we have some custom database. We are just going to close this window. And maybe you remember that we have this filter button here. And we can not only filter our compound list by MZ values or by retention time or by scores, but we can also filter it by hits in structured databases. So here you have these basic filter options, but at the bottom you have this box, hit in structure DB. And maybe not all of you have this box. If you don't have it, it just means that you haven't used a Sirius version, but it's also not a problem. I can also show an alternative way later on. But if you have the latest Sirius version, you have this box here, and then you can select that you want to that you only want to search, or that you want to filter your list to this structured database. So the one we just imported, that we just created, however you named it. So if you imported it, it should be this custom db-hydrogen pubchem, or if we just created it, it would be pubchem- or whatever you named it. So just remember, you can filter by any structured database, but as we just created a custom database, we want to filter by this custom database. And again, we select this and we click another option here. We can check for hits, for structure hits, if they are contained in the structure databases. We can either only check the first candidate for a compound, but we can also check, for example, the first two structure candidates or the first three or so on. For this example, we are just going to input 2 here. So we want to show candidates where the structure or compounds where the structure is in the first 2 structure candidates. Yeah. You mean the databases? Yeah. Before we just use the filtering option by MZ, if you remember, and now we can filter all our compounds if we have hits in particular structure databases. So this list here on the left, where we have 6,000 compounds, we can filter them to only show compounds where we have a hit in a particular structure database. So for example, you could only show the compounds where you have a hit in HMDB. Yeah, this just means that you have not imported the custom database yet. So you will probably have the other list, but yeah, it would work just the same. So I will show it for the custom database, but you can also do it for another database if you want. So I've ticked this, this custom database that we imported, and then we click again on apply. And now it is filtering our compound list. It takes a little bit. Okay. Is it still filtering for some of you? How many of you now have a very small list of compounds in this view? Okay, at least a few. For how many of you is it still running? Is it still showing GIF? Okay. Yeah. But this is also is not a problem if you have not done this custom database part, because I can just give you the feature ID, then we can look at it together. So now we would see all these compounds that we found in our custom structure database. So now we have 3 structure hits, and maybe so everybody can follow along. I will just give the feature IDs. So we will look first at this feature with the feature ID 4511. So even if you have not made your custom database, you can just type in 4511, 4511. It is also in the markdown if you have it still open, so that everybody can look at this 4511, this particular feature. And again, if you would type it here and you would hit enter, you would get only this particular compound. Is there someone where it doesn't work, where you don't have anything here right now? Do all of you see this compound, this compound in this window? Okay, maybe you get 3 because the search here is just a text search. So if you, for example, so this feature ID is example series 4511, right? So maybe you get also a compound that is named example series 45111. You would also find it. So maybe, for example, you could put an underscore before it, and then it would, you would only get this one. Yeah, but it doesn't matter if you have more structures here or more compounds here. Yeah, we're just going to look at this particular compound, this example series 4511. And I don't want to tell too much about it, just what we can see here, that we actually found diphenhydramine. So although it says allyl, this is actually just a structure of diphenhydramine, because allyl is apparently just the brand name for diphenhydramine, or another name at least. So if we again would just click on one of these buttons, and so maybe first, before we click on anything, you can see that, yeah, when I make it bigger, you can see that you have now more boxes here at the bottom. If you were able to search in the custom DB, you would have also these custom databases here. And this would just show that this particular structure is in our custom database. So here we can see we have a hit in our custom DB diphenhydramine pubchem. And also we created a few other custom databases. So for example, we used the tool biotransformer to also create a custom database. And also we put in just the structures from the publication, just as a sanity check. Yeah, but let's just click on the HNDB link real quick, and just to confirm that we actually have this diphenhydramine here. Yeah, and you will see if you click on it, you would see the common name diphenhydramine. And maybe because it was a little bit too quick before, just how would you judge that it is a good match? Here, for this example, we can actually see another thing. We can see that this structure is contained in our training set. And this, especially if we have good scores. So for example, if the CSI FingerID score is good, which it is for this example, and if we have found the structure in our training set, it is especially a good sign. But again, like the one thing I always try to do is right-click and use this highlight matching substructures option. And then if you also get all the structure highlighted in blue, it is a good sign because the predicted fingerprint matches the fingerprint of this structure. Okay, we could also again look at compound classes, but I'm not going to really go into detail. Just that this compound class prediction also seems to confirm what we found with the structured database search. So these classes, if you click on them, or if you know something about these classes, they also seem to fit diphenhydramine. So let's look at another example real quick. Let's so I filtered by our custom database, so I only have these 3 compounds in this list. But if you don't have it, again, we can just type in the next example feature ID. So the next example we want to look at is this 4194. So everybody that has a Sirius workspace, just type in 4194. And maybe also include an underscore because so you get a better match for this text search. And then you would see this feature. So does everybody look at a compound right now? Does everybody have something in this list and can click on it? Okay, at least nobody says anything. Let's just look at it real quick. And let's go to the structures tab again. So maybe, especially if it was a little bit too much, what most people want to do, or what maybe is the most common view that you use in Sirius, is probably the structures tab, because mostly you want to know which particular structure the compound belongs to. And here you can see that we also have a match, and here this match is diphenhydramine. And this also, you can see we have found it in our pubchem custom database, but also it is in the publication. So it was also mentioned in the publication. And maybe you remember it from the last session, from the MD-MIND session yesterday, where Robin actually looked at the molecular network in MD-MIND from diphenhydramine. And he could also see annotations. And one thing that I think wasn't highlighted was this one, where also Robin assumed that we probably have a methyl loss somewhere here, and this fits to this particular structure here. So maybe if I just go back real quick. So here we have the view again of our three hits for the custom databases, and here we have diphenhydramine, and if we just go to the second one, we have pretty much the same structure, but without this methyl group here. Yeah. So I think we're also pretty low on time. Yeah, so this is also the most of the things I want to show you. Yeah, maybe one thing I just want to mention real quick. You can export summaries. This is also an important feature. So especially if you only want to know what annotations were found, you might want to use this option to write summaries, for example, of the top hits. You will produce some table and you can just write it somewhere. Also, this file was already created, it is in the GitHub repository folder, and soon we are going to use this file to import it into Cyberscape. just to already give a quick heads up. Yeah, question? Yeah, the question was if you can also export the compound classes. And this is just in this dialog. So this option that is ticked is the top hits option, but you can also, here you have all the options for Canopus, so all the class predictions. So if you would just tick these options, you would also write all the compound classes that were annotated.
How many top hats does it?
I think, so if you just import it, you would get for each compound, you would just get the top structure. But you can also, for example, use this all hits option, and then you would get all the structure hits that we found. Yeah, that was all I wanted to show you.